Welcome everyone. So today we are going to resolve some really interesting problem which you come across in the LeetCode. So this problem relates to the matrix problem, and we will touch some bubble sorts, and in the end of my explanation we will see the more optimal solution for this task. So before to start ruminate about this problem, let's introduce what the problem is. So we have some I have no idea what the shape is really, but the same type of let's say matrix, and the some cells in the matrix fill the some different of chars. Some chars is a rock or rocks if we talk about each cell separately, but some of them are empty, and the third char is some obstacle. For example, if we look at this example, we see this piece of cells is an obstacle, and visually the problem called like this. So we have some matrix. We rotate this matrix right side like a clockwise by 90 degrees, and imitate the some gravity, just like rocks. Our rocks in this part of matrix fall down in this part of matrix. Like if we take this rock, we seeing that this rock moving in this cell like here, because this gravity works like that. We rotate and that our rock down in this cell, and this thing happens for this example as well. So we have some row, just rotate clockwise in 90 degrees, and our rock fall down in this cell. So the question is, in the input we have a two-dimensional array which filled some chars. Depends on the chars, but so this chart denotes we have a rock, this char is empty, and this char means we have obstacle. So there's a particular detail of this problem, but anyway, we have to consider it. And we have some two-dimensional array which denote the matrix, the row and columns, like we're used to. And we rotate the matrix for clockwise, and all of the rocks have to be down, they fall down until don't come across in the bottom or to the some obstacle like here. So before to start to solve the problem by yourself, I suggest you have to think and ruminate what idea or ideas come up in your mind. But it might how to say it, it's a good thing to force your brain, and at the same time it push your brain to developing in this sphere. But anyway, if you have no idea how it can be resolved, so let's move on. So practically this task has to be divided by two general parts. The first part, we have to rotate this matrix somehow, because it doesn't matter will be these rocks fall down or to bottom or the obstacle part. We definitely know that this matrix change these shapes. Like we have 2 rows, 4 columns, but now we have 2 columns and 4 rows like this. So definitely we have to somehow rotate this matrix. At the same time, the second part, we have to move our rocks until we don't encounter some obstacle or the bottom side, the end of the matrix. So let's first of all, let's consider this second part. So how many approaches we have? So the first approach, let's imagine we already rotate this matrix, and stop. I changed my mind. Let's start with example by rotating a little bit. Put it introduce you with rotating, because it will be hard to understand my ideas later. So we have some matrix, we have to rotate it, and at the same time we have to change this rocks, this position. So before to start talking about shuffle or the change position of rocks, let's talk about the rotating part. So in order to resolve the problem, we have to recognize the pattern, or the patterns of how these changes happen. So we have some matrix, for example this one, and we have another matrix which is a result of rotating. So literally it's happening like this. So we take this matrix and rotate in 90 degrees, and we will see like this rotating process. But anyway, numbers has to be rotated as well. So in this literal example, visual example transfer to this result, and we have to see this pattern. Like we have this row which start with 0, and the columns which is 0, 1, 2, 3, and we see these changes. Just our 0, we start row and columns 0, 1, 2, 3 to transfer column 3 and rows 0, 1, 2, 3. So there's like changes. These changes in what is happening in our programming. So we have some row, we have some columns, and we will see these columns transfer this number, and the rows transfer these numbers. So if we will take and try to transfer each row by another column individually, we will see the same pattern. So the row, column, and we will see how changes is happening. Just this part doesn't change, but this part changes all the time. And the question is how this part changed. So we will see this part changed. We have a 0 row and the last column, and then when we move forward, for example the row move down on the matrix visually, we will see this row decrement and the column increment by 1. So in this part, increment, decrement, increment, until we will reach the end of this our matrix. So and the question is, we have to change when we transfer our matrix. This matrix, we create some matrix, because it doesn't mean the matrix is a square, is a strictly square. So we have no idea how many rows and columns we have. It might be like this, for example, not strictly square, like rectangular, for example, or 2 rows and 3 columns, for example. So it doesn't mean this strictly square. And we create new matrix, which is a represent new matrix when the row is a column and column is a row, because we rotate eventually. And then we fill this matrix from old matrix to new one, and followed by this pattern, just to traverse the row, iterating the row, and put the columns to row, and put the row from here. So let's consider the example by TypeScript. So it's not difficult, don't afraid. What we are seeing here. So we have two variables, first and second one. I decided to allocate new variables because it's more comfortable for our mind. So the first one is a row size. The second one is a column size. So then we create new matrix, which is I was called rotated. It means the result of our new matrix. And the rows, how many rows we have, it depends on the columns old one. And the same question, how many columns we have, it depends on the how many rows in the old one. So we create new matrix, and then we iterate old matrix by row and columns, from left to right, from up to down, classic iteration. And then we change some positions. So we take the box grid is the old matrix, by the way. We take from the old matrix its row and column, and then put the row and column in transferred. So for row, we take the column, followed by our assuming from here and these examples, and then we calculate the column. How calculation it works, or is work. The calculation works like that. We see the row and column and decrement in incrementing things. So definitely when we have a row like here, we have to opposite number of column. Just for example, we have 0 row but last column. We have a first row but minus last column, and we do it literally like this. We have a maximum rows size -1 because the index starts with 0, and minus the current row. Just in this formula help us to find the appropriate coordinate. So it might be easy for you, but anyway, it takes time. So okay, we will solve the problem with rotating part. Now we are able to rotate the old matrix to new one, just like this example. And let's consider the second part of our algorithm. So let's imagine we already rotate this given matrix. For example, we had this one and rotate, but we still have this position and this position, right? So I a little bit confused you, I think, but before to rotate this matrix, I change this position of rocks. So what I'm suggest. So before to rotate, let's take every rock and try to move in the right side, because eventually we know this in the end of rotating this, all of the rocks will be closer to right side. For example, in this example we have a sum matrix. Before rotating this matrix, we know this finished result of our matrix when this rock closer to this rock. If we rotate in the opposite direction, this our rock will be closer, will be here in a horizontal line. Or example here, so if we rotate this rock until we don't come across with obstacle, so we have to move this rock in the right side. and then we will rotate this matrix, or might rotate this matrix. Anyway, if we're doing the same thing in the opposite direction, so like backwards, so it will be the same. Just rotate 90 degrees and opposite clockwise, we will see this rock here. This rock doesn't change, I mean, don't move at all. And this rock will be in here. So it means it doesn't matter what is consequences or the order of algorithm. We might rotate and then moving, or we might moving and then rotate. So it will be works, but a little bit different way. And what I suggest to move our rocks horizontally line and then rotate. Rotating mechanism really don't care about what is inside in this matrix, rocks, empty, and other things. Just transfer the sum values to another matrix. And the first step, the second step we already know, but the first step we have to transfer our rocks to right side until the bottom or until the obstacle. So how can we do that? So yeah, I know the two approach how can we do that, not optimal and optimal solution for that. Let's consider this bubble sort. What is bubble sort? It's a common way to sorting some things in an array, for example. So, and the first idea which might come up in your mind when you start thinking about this problem. And how does it work? Just a little bit reminder about this chars. So this chars is a rock. This period it means is empty, and this symbol it means we have an obstacle. So how can we move our chars? So literally it might be two directions, from left to right and right to left, and it depends on your preferences, but I will consider from right to left side. So how does it bubble sort works? We take this rightmost position, rightmost char, and try to find the empty cell. Just reminder, the empty cell is this cell, this period, right? And when we will come across with the empty cell, we try to change with next or from the left of this position next by follow our direction char. For example, we have this right, our pointer, and left, our pointers. So we always will be start with this rightmost pointer until we don't reach this left side. For example, so we have a left pointer or right pointer and start to looking for the appropriate. So in the first char we're seeing that we have a period, but the next char is not appropriate. There is an obstacle, we can't change them, right? So what we are doing, we move our pointer next. It's not an empty char, so we can't do anything. So there is an obstacle, we can't move obstacle, and we only can move or rocks or empty. But in this case, we are going to move empty cells. So we take the empty. We understand, so it's not empty as obstacle. This next char is a rock. We understand, so rock we don't have to anything, and we next and move our in left direction our pointer. So and then ta-da, we have what we have. we have an empty cell. We can change this empty cell with next one, but it doesn't make sense for us, but we can do, and we do it. So we change and move our left pointer further, change, and here what we have this empty and obstacle. We don't do anything because we can't move the obstacle. So we move our left pointer, then move again, so we come across with the rock. Rock can be changed, so move further. So we changed something, but in practice we don't change anything because visually we can see, so it doesn't change. And what the next? Next, we understand, so we try to move some char, abstract char, to the left side, and this char has to be sorted, but it's not in real life, I mean in this particular example, but it has to be. So next we're standing again, and we will be moving until this char, because this char already sorted. So, and down on me, I'm not choose appropriate example. Maybe try to look at this one, or maybe this example when I practice already didn't will be sorted before, but sorted right now on my screen. So we have 2 pointers, a little bit down. We have 2 pointers and move this the left to the right. So we will see this rock, do nothing. We will see the empty cell, and next one is a rock. So okay, we can change this position. We change the rock and the empty cell. So good. Next one, we encounter the same case. Just we have to change the rock and empty cell. So we change it. Again, the same situation, we have to change, and we change. Great. Yeah, we might change. Okay, but it doesn't make sense. Move further. So now the first position of our array already be sorted. Bless God, we did it. So now we are starting again with 0, but at the rightmost part of the array. But anyway, we start at 0. I might call 0 because it's easier for our brain. And we start, move further, rock. So we will see this our row, I mean our array already be sorted. If we just imagine we rotate, so it's not a comfortable visually, but anyway, we'll see this nothing rocks can be down or to bottom or to obstacle. So we are doing all of we can do it. What next? The next is this algorithm calls bubble sort, but we don't usually we're used to for numbers, but now we're sorted by some other mechanism, but the gist of the algorithm the same. Bubble sort will take from this position and change their places, like a swap, and if we do, of course, and if we do, or if we will do, so we definitely will do, and we change, and then until we end of the leftmost side, we understand, so this position already be sorted, and we try to change until this position, and then try to change until this position. So it's pretty simple for many of us who are pretty familiar with it, but not for all of them. And this solution represented here. So what we are doing, this piece of code has to be familiar for us because we consider in rotating mechanism, but this piece of code is not familiar for us. This piece of code is a bubble sort or shuffle, or what would you prefer? And we have 2 loops, and and at the same time I'll allocate the extra variable just to denote the particular row of our matrix, just the flat array. And then we have two loops, and the first loop is the right pointer, the second loop is a left pointer. So we start of the end of matrix, but to be honest, this output outer loop we can implement by while loop or the sum counter. So let's consider the inside loop before to consider the outer. So we have this loop, left counter from rightmost index and until we end of 0 index in the first iteration. In the second iteration it will be index by 1, and the third iteration it will index by 3 because we calculate the index. So the calculation of index and this the size of the array -1 and minus right is a counter which helps us to calculate the distance which is already be sorted, because how I said before, so when we use a bubble sort, so the right pointer move to the left side until the sum index, and the next iteration it will be this pointer, it will be sorted by this index, because we assume, and the algorithm works like that this after the first iteration this index already sorted, and this code of line helps us to calculate it. So then we doing some extra checks, just this particular index is an empty cell, and the next one on the left side is a stone. So allocate some extra constant because it's easier for our brain. Just don't operate the symbols, and it's not easier to memorize all of them. And the question why I have to allocate some extra memory from our brain for not useless things. And okay, we are doing compare that's left from the current, the left index is a stone, so we can change, and the extra check that the current left is not the greater than 0. Why is it matter for us? Because we look at the left side, and the left side us is really important. So probably we are in 0 index and we don't change anything. And then this the swap construction, I mean this swap statement, it's really common in JavaScript. Just change 2 values in the array, and it calls swap. So pretty easy, but if it's not pretty easy for you, but spend some time to resolve this problem. Individually, it depends. What next? The finished part of my video is how can we improve our algorithm. This time complexity of algorithm is in this part when we change the values on the matrix, we iterate each row and each column. It means row multiply column. But plus for every column we make bubble sort. Bubble sort, it's n square, and for every row with row length we do the row length square. It means for every row size, for every row we make some row length square. It's not pretty efficient, But anyway, it works, and even it works for LeetCode. But how can we improve our algorithm? And what is interesting, this improvement because we the coding is decision easier, but maybe it's not more obvious than previous one. So what idea behind this? This idea is pretty easy. So we might reverse all of the stones, or before I said like rocks, but stones, rocks, anyway, it doesn't matter for this task. We might take any stone, or okay, we will see rock. We will continue these things. Rock. We will take any rock and change for position when the potential might be. So let's assume this the first position, rightmost position, is acceptable for changing, and we start to move left. Pay attention, we are still use the 2 pointers for this algorithm. We start to move the left pointer to the left direction. Okay, start to moving. We move until we don't come across with rock. So we came across with rock, and we understand. So now our assuming about this position is optimistical that yes, we already can change. So and we do it. We change empty cells with rock. Then we increment, literally increment, but like move in the left side our leftmost rightmost empty cell or rightmost empty position, because this cell already filled. And what we are doing then, we are take this pointer and move further in the left direction. We move until we come across with rock, but we don't have rocks anymore. Okay, we will see this. We are seeing this already be sorted, and so just take another example. Just give me some time to change into like this and like this, and maybe the obstacle and here, right? So what we are going to do here? So we have a left and right pointers are assuming the same, this rightmost here, and we try to move our left pointer to the left direction. Okay, we are start to moving. Then we came across with obstacle, and now what is really interesting, and we understand, so that our optimistical pointer has to be after this obstacle, because we can't move or rock jump over this obstacle, because when we rotate our matrix, all of the rocks fall down until they can come across with this obstacle. So in what we are doing, we move this pointer and move our rightmost empty cells here as well, literally here, and we start to move further our left pointer. We understand, so there's a rock, and what we have to do right now, just change the rock with the rightmost empty position, here. So we change it, and the same mechanism, just to move the left pointer to the left direction, and in the same iteration right pointer to the left direction, because this cell already filled with rock. So we take this rock and see the same thing. Okay, change it, and step left and right pointer. So like we see, this represented array already be sorted, because all of the rocks fall down, encounter the obstacle, and that's it. it works. And this is pretty efficient, because we just sorted all of the rocks one iteration, and the cutoff which is implemented this algorithm here. So we don't consider this part, because this is a rotating part, except the shuffle here, because we start with shuffle and then the rotating part. Okay, the shuffle algorithm, what we are doing right now. So this loop, only single loop, and we start this rightmost index until the end of the 0, while this left greater than equals 0. So then we have some conditions. So the first condition, if we encounter the obstacle, it means we have to our rightmost empty column move to the left, the next step to the left direction, and continue our loop. Or the second option, if we encounter the stone, or like I said, the rock, we have to change this, the same thing, the shuffle, this swap, and the rightmost empty column has to be moved forward for our direction to the left side. So if we came across the obstacle, just move forward this only rightmost empty column pointer. If we encounter the stone, swap in this line and move our right empty column. So the left will be the left will be my next step by this condition on the general statement. So it works like that, and it's pretty much efficient than previous one. So the time complexity is rows and columns. Yeah, definitely this loop takes some time, but in the boundary of O big notation, we don't consider this extra loop, and we understand. So the complexity is iterate all of the rows, all of the columns, and transfer our matrix from one state to another. So we are doing in this piece of code. The space complexity the same, because we'll create a new array, but different rows and different columns, but this total size of rows and columns the same. This is my explanation of this task. I do my best. I have no idea how it will be another side, like a listener or watcher, but hopefully I think it will be fine, or it's fine. Thank you for watching, and put the button of subscription. Definitely, if you have some idea or proposal about this video, write down in the comments on the video. So thanks a lot. Bye.